35. This is solving an equation for unlimiteds. And again, cosine kind of indicates that we will probably be looking at 2 pi, but we have to solve it and we'll figure it out from there. So we're going to solve this for what x values do it. And remember, this plus 2 pi means you go around the circle 2 times. And so this was kind of like number 30. Let's see, we got this one is 2 cosine 1/2 x minus 1 equals 0. We need to solve for x. So we'll add 1 to both sides. No special thing to do yet. 2 cosine of 1/2 x equals positive 1. We'll divide by 2. So the cosine of 1/2 x equals 1/2. Okay, so where does that happen? It will happen, cosine, so this is the input, whatever's in here has to be equal to what gives us a cosine of 1/2. That happens at, not that one, pi 1/2, pi over 3. And the other place where we get a positive 1/2, x being positive 1/2 is 5 pi over 3. So there's 2 places. So let's do that. So one place is pi over 3. The other place is down here at 5 pi over 3. Okay, so whenever 1/2 x equals pi over 3, then that would work, right? I mean, then the result would be cosine of that would be 1/2. That's one of the solutions. That will happen, and then we can add 2 pi to that, and we're back around to that circle. So we ignore the 5/3 right now. So then we add 2 pi k, and then so I'm going to do it that way. 2 pi, add 2 pi to it, and multiples of k. They do it 2k pi, but that's harder to understand. It's 2 pi multiple times. Okay, that's the way we want to think of it. And then again, they do k as an element of the z's integers. Okay, important, but that's what it is. So then now we need to solve this. So we multiply, we want to solve for x. So we multiply by 2, cancel there. We multiply this side by 2, but the 2 has to distribute. And I had forgotten about this. You need to set it up like this until we were working together today in the meeting, Sunday meeting. So that was a very valuable meeting for me. I probably would have figured it out as well. Well, of course I would have, but you all were very helpful in pushing me through. So we distribute here. You get 2 pi over 3, so that times that, and then you have to multiply this. You get plus 4 pi k. And again, they'll do 4k pi, but I like this better. Now that's one solution, and then the other one is over here. So we do the same thing. We get 1/2 x equals 5 pi over 3 plus 2 pi k. Okay. Now the time when we only need k is if the solution was like back this way. Notice I could just add pi and I got it, and then I add pi and I got it. That usually will happen if we have a tangent, or if we're on the poles, like a positive 1 and a negative 1. But we're not. So for cosine, we have to have the 2 solutions, and then we keep adding 2 pi to it. Okay, and we do it first, and then we multiply by 2 to solve for x. So this side we multiply by 2. We have to distribute, and so we're going to end up with 10 pi over 3 plus 4 pi k, or 4k pi. Right, that's the other x. So let's see if we can get this set up. So mark these. Oops. there's one answer. There's the other answer. Okay. And then we come over here, and now we just need to enter them. 2 pi over 3 plus 4 k pi. Then we do an or, 10 pi over 3, again, plus 4 k pi. Okay, just like move it together. Okay, so that was that one, 35.